Well, great. Thanks everyone for joining us today. It's the 52nd webinar of the Australasian chapter of the International Geosynthetics Society, and we are privileged today to have members from IAGI, the International Association of Geosynthetic Installers, presenting to us on geosynthetic installation best practice and IAGI's role. So just a bit of a background on the International Geosynthetics Society. We have chapters all over the world, and which we are the Australasian chapter covering Australia and New Zealand. We have over 2,800 individual members, 138 corporate members, and 8 premium corporate members. But really importantly, we have 640 student members, and student members are free. So you get access to all the RGS resources and newsletters at no cost. The best way to join, go onto our website and go onto the membership section, and you'll see the various options for joining there. The website also contains our webinar library, which has recordings of all the webinars that have been presented by the Australasian chapter over the last few years. A great resource for going back over and listening to things, or if you're new to the industry, finding out from experts in the field what they've given presentations on. Just also like to remind everybody, we are running the academic masterclass for geosynthetics in 2026. So the educator program, this will be presented by Professor Tim Stark and Professor Malik Bouaza. It will be in November 2026 in the Gold Coast, and applications to that close at the end of July. So any academics who would like to include information on geosynthetics in their course content, please get in touch with us. Then also just like to bring everyone's attention to GeoANZ 2027, the third GeoANZ conference organized by ACIGS. This will be held in July 2027 at the Pan Pacific in Perth. And the theme for this conference would be safer, greener, smarter with geosynthetics, future-ready mining. So trying to focus on the use of geosynthetics in mining. Abstracts submission dates are open and close at the end of this year. So please get us your awesome projects and new applications of geosynthetics in this area. I'd like to thank our sponsors who help keep ASIG's doors open and help us give presentations like this, Platinum and our Gold sponsors. So the presentation today will be given by 3 people who are in the IAGI organization, and Brian, I think, will talk about what each one's going to speak on. Firstly, Todd Harman from Hallaton, Brian Fraser from Layfield, and Nick Morris from GeoQ. And our webinar sponsor today is Merit Lining Systems, and they will be giving us a short case study at the end, and then we'll have Q&A after that. If you'd like a CPD certificate from your attendance today, please get in touch with us and we'll get that across through to you. So I'll just stop sharing quickly. You're having an issue with stopping sharing, as I seem to have lost my screen. What are you guys seeing at the moment? Just my background?
Yes, it is desktop.
Oh, there we go. Not exactly sure how to stop sharing, Alicia.
Okay, I will try to
if
do
you
it.
if you can shut me down, then that might help.
Yeah. Brian, you can share it now.
Thank you.
Okay, are you seeing my screen?
Yes.
Okay, well, thank you. It's a pleasure to be here today and have the opportunity to present with Todd and Nick. So today we're going to do a quick overview of IAGI's history and its membership. We're going to be discussing IAGI's new Municipal Solid Waste Best Practice Manual. We call it BPM. Nick is going to cover the Certified Welding Technician, the CWT program, as well as Nick will cover the role of IAGI proctors in the CWT program. And Todd is going to cover the Approved Installation Contractors, AIC program, as well as give us an update as the president of IAGI. And then we'll turn that over to Alicia. And let me engage this presentation. Okay. So just a day in the life with the IAGI crews. The photo on the left is the Camanco crew in deploying a double-lined geomembrane system for a mining project in Nevada. And the project on the right, that is a 4 million square meter high-strength geotextile fabric project being installed for a tailings cap in Alberta by Layfield, Canada. So a little bit about IAGI. We were founded in 1995, so we're just over 30 years of age, and the International Association of Geosynthetic Installers represents geosynthetic material installers globally. And IAGI was founding members had a deep commitment to protecting the environment, and that commitment remains in place today. Also, just make note that IAGI has a long history in Australia. As an example, Max Brady, formerly with DDT Lining Company, has served two terms as a president with IAGI. And we do have a number of IAGI members and from Australia, as well as CWTs. So IAGI's mission is to provide a forum for geosynthetic installers to advance installation and construction techniques and to strengthen the knowledge and communications within the industry. And we promote the pillars of installer safety, quality, productivity, and industry best installation practices. Just quickly, our board of directors, there are 8 of us. Starting on the top left is Todd, the president of IAGI, as well as president of Hallaton. To his right is Phil Denis from PRD Geo Consulting in Canada. To his right is Nikki Arrojo from SIGSA, Panama. And the top right is Eric Lamartine from Green Earth Environmental in Saskatchewan, Canada. Bottom left is myself, and I represent Layfield in the USA, Canada, and Australia. And to my right is Gus Fossey, the general manager for Demtech USA. And we also have Evan Bale from Camanco in the USA. And finally, Marco Horojo from SAI Mexico. So we're all installers, we're all in the installation business, and we have combined over 200 years of installation experience. So our membership today represents hundreds of installers. We have many of the top geosynthetic installers as IAGI members. We are in 23 countries touching 6 continents, and our members are, well, primarily geosynthetic installers, also are CQA service companies, consulting engineers, manufacturers, fabricators, and equipment suppliers. And the photo on the right, just a quick kudo to Demo Dave, now with DMS Equipment, and he's been a pioneer and major contributor to IAGI over the years. So we cover all of the main environmental containment markets. You'll see us active in municipal solid waste, whether landfill liners and closure systems, and hazardous waste landfills and hazardous waste sites. In oil and gas, we're involved in upstream, midstream, and downstream operations, and you'll find us in all the main mining regions of the world. We're active in municipal water, whether it's protecting potable water or in wastewater treatment. And in agriculture, we're into everything from lining of lagoons and canals to anaerobic digesters. We do a lot of work in soil remediation and brownfield sites, as well as recreation and decorative ponds. So lots of different civil engineering and construction applications, including lining of transportation tunnels and commercial vapor barriers. So we're going to talk about our best practice manual for the municipal solid waste. So over the past few years, IAGI has worked to create a best practice manual for installation of geosynthetics in municipal solid waste. And this was a few years in the making. We really chose the municipal solid waste because it is critical containment. We're dealing with multiple layer composite systems containing leachate, and we're in all regions in the world, and we're major cities, towns, and counties. This BMP also recognized the various regional differences in countries, as well as different installation methods and different regulatory requirements. And it also was important to address past and current installation problems with quality workmanship and construction. So we've released 12 chapters as part of the initial publishing of the MSW containment manual, and we have 4 more that are going to be released very shortly. And it's currently free to IAGI members, as well as for a short period of time, and then it will be paid. And then the non-members will be able to procure a paid version from our website in the near future. So quickly, just going to cover the main chapters. Myself and Todd and Nick will cover the chapters. Starting off with chapter 1, introduction. This really keyed on the importance of improving installation practices and quality. Also discussing the importance in the containment industry of landfill containment systems. We discuss in chapter 1 certified welding technician program, as well as the approved installation contractor program. Chapter 2 is on pre-construction meetings, and this really talked about planning. The importance of meeting early in the process, a strong, well-organized pre-construction meeting, and the importance of bringing everyone to the table, the owner, their representatives, including design engineers, CQA leads, general contractors, and the geosynthetic installers. Geosynthetics matter to a review in the pre-construction meetings, and the geosynthetic installer needs to be at the table. We also discussed in the pre-construction meetings a review of the specifications, the contract documents, and the approval process. And we discussed the geosynthetic panel layout, construction sequencing, and the scheduling plan. Chapter 3 is on submittals. So we really keyed on the submittals primarily related to MSW projects, municipal solid waste. We talk about the manufacturer's qualifications and MQC program manual. We talk about the material specifications, the installer's qualifications, the material and installation warranty, shop drawings, and work plans. And we have this really neat chart in this chapter that shows, as you see on the right, we show the role of the various stakeholders, manufacturer, installers, CQA leads, etc. We show the recommended qualifications and the certifications to consider on your projects. So Nick, over to you to talk about chapter 4, storage and delivery. Nick?
Nick, you are muted.
Oh, sorry. Can you hear me now? You got me now?
Yep.
Yeah, okay, cool. So chapter 4 highlights the relevant ASM guidance for storage and handling and the importance to verify each role upon delivery, the safe offloading practices and the suitable storage locations for the project materials from damage. The chapter gives practical guides to how the material should be stored, received, and inspected to maintain product traceability throughout the project. It also reinforces the need for good housekeeping, material tracking, and documentation throughout the project. Okay, next slide, please. Okay, cool. So chapter 5 is material testing. So chapter 5 provides an overview of the testing used to confirm the geosynthetic materials to meet the project specifications and the performance requirements. It highlights the different types of testing, including physical, mechanical, and the long-term durability tests, along with common quality control and quality assurance practices throughout the project. It consolidates that the successful programming relies on an understanding of the result turnaround times, planning considerations, and several key ASTM methods commonly referenced in the industry. As you can see, some of the lists down the bottom there. Next slide, please. Cool. All right. So subgrade. So chapter 6 focuses on the subgrade preparation and management. The basis of the chapter is that the subgrade is the foundation of the lining system. and the subgrade quality directly impacts the long-term performance of the lining system. Chapter 6 provides a good guide to subgrade acceptance criteria and maintaining quality throughout construction, managing installation delays due to inclement weather, equipment, safety concerns, and implementing practical de-risking. It also highlights the importance of sequencing earthworks and the lining installer to minimise the reworks and delay, which ultimately creates quality issues. My key takeaway from this chapter is that all stakeholders have to be aligned on the project acceptance criteria, and a clear understanding of what constitutes a pass and a fail for subgrade preparation is key for the installation to commence. Next slide, please. Right, so Chapter 7 is based on geomembrane deployment. The chapter covers the different types of geomembrane materials used around the world and how different regulatory requirements can vary between region to region. It discusses the key factors that contribute to successful deployment, including subgrade readiness, storage and handling, weather conditions, deployment methods, and other safety considerations. The chapter also highlights the importance of planning, equipment selection, and the ballast management and anchor trench preparation to ensure efficient and safe installation processes. Next slide, please. Look, Chapter 8 focuses on the geomembrane seaming and tie-ins. The chapter covers the method used to join geomembrane panels, including fusion welding and extrusion welding. It gives detailed guides on trial welds, production welds, and the key ASTM and GRI standards for the different test methods used to verify seam quality. The chapter also reviews both destructive and non-destructive testing techniques, as well as considerations for challenging conditions such as cold weather installation. So that was that one there. So guys, what I'll do is I'll hand it over to Todd, and Todd will talk about repairs, Chapter 9.
Thanks, Nick. Yeah, Chapter 9, repairs. Can't get away from them. They're expected in geosynthetic installations, but are not automatically evidence of poor workmanship. They may result from normal installation activities, destructive seam testing, cutting around appurtenances, patches, accidental damage from wind, equipment, weld burnouts, or cover placement. Visual inspection remains essential even when more advanced quality assurance tools such as electrical leak location are used. Holes, wrinkles, cuts, tensioned areas, and raw material defects should be marked, clean, evaluated, repaired, tested, and recorded. The geomembrane is the most important layer, and repairs are critical, but so are the other layers. The BPM goes through repairing all layers of geosynthetics. Next, please. Kind of a continuation on repairs. We emphasize that all repairs must be documented, no matter how small. And this is one that I harp on all the time. If you didn't document it, it didn't happen. I don't care whatever happened, a month, 6 months, 2 years from now, they want to know what happened in a certain section on the cell. You got to come up with documentation, say, well, here's what was done. Here's where we tested it. I can track this seam back, and here's where it happened. If you really want to go to dig it out, and we'll look at it. There are 3 main reasons for leaks: manufacturer, the installer, and the contractor. That covers the geosynthetics. Rarely is it from the manufacturer. Installers make mistakes, and weather can help with that part of it. The general contractors, probably what I've seen more of is when they're the covering layers. A new operator gets on the site, he's hits it, digs down into the layers, probably all 4 or 5 layers, and quickly covers it up with the aggregate because you don't want to get fired again. That's where I think most of the holes that we observe on our sites are coming from. A repair log should include the repair location, date observed, person identifying the issue, damage description, person performing the repair, related testing data, and a repair number that also appears on the as-built drawings. And that's pretty much everything you're seeing in the picture on the left. Next, please. Chapter 10, soil and aggregate cover placement. The engineered cover layer protects the geomembrane from operational damage and helps support leachate collection. Placing soil aggregate over a liner is itself a high-risk activity because equipment, angular stones, aggressive pushing, improper fill thickness can damage the hidden geomembrane. kind of what I just described with the operator. The cover placement method should be agreed upon before work begins and should involve the installer, earthworks contractor, engineer, and third-party CQA technician. The quality of cover material matters greatly. Oversized stones, angular aggregate, sticks, debris should be removed before placement. Heavy equipment should not drive directly on the geosynthetic lining system. And that kind of depends where you are around the world. In writing the manual, we kind of came up with a lot of different areas where we do that. We have to because of this. Well, okay, we tried to make it uniform for everyone. Even improved equipment must operate only over adequate cover thickness, with attention to tire pressure, ground pressure, turning radius, proximity to pipes, trenches, and weather conditions. Bottom-up placement is critical to prevent a slope failure. Working around temperatures is also important to prevent undue stresses on the lining material. Warm geomembrane expands, and if covered while expanded, later cooling and contraction can create stress and tearing. Cover thickness should be routinely checked with non-damaging methods such as hand excavation using plastic tools or laser level survey equipment. Next, please. Chapter 11, GCLs, the geosynthetic clay liners. The importance of GCLs is pretty well known. They're a composite material made of geosynthetics and bentonite. They're commonly used as hydraulic barriers or secondary containment layers in landfill systems. Their performance depends heavily upon handling, hydration control, subgrade condition, orientation, overlap, protection from premature moisture exposure. The chapter in the BPM explains why GCLs matter. Bentonite swells, it gets hydrated, very low permeability of barrier. GCLs can also reduce installation time versus a much thicker compacted clay. BPM notes that 1 truckload of GCL rolls can provide performance comparable to 150 truckloads of clay. That's a lot of trucks. Chapter 11 covers GCLs as highly effective but sensitive materials. Detailing delivery, storage, and handling must prevent roll damage, bending, shifting, moisture exposure, premature hydration. Rolls should be kept wrapped, supported off the ground, protected from ponding water, and generally stacked no more than 3 rolls high. Before deployment, the subgrade must be approved for smoothness, compaction, moisture content, and absence of protrusions. And let's get the next one, please. Chapter 12, geonets and geocomposites. Geonets and composites are used for more to move liquids and gases through the drainage or venting systems. Their drainage core may be a biaxial, triaxial geonet, perforated mini pipes, or similar drainage conduits, usually wrapped in a bonded with geotextiles. The geotextile component is critical because it filters, protects, and helps prevent soil or waste from entering the clogging and the drainage core. Chapter 12 focuses on protecting drainage performance. The geocomposite rolls should be installed carefully and not allowed to unwind uncontrollably by gravity or down the slopes. Panel overlaps are critical. This chapter references GRI guidance recommending the overlap in seaming types, typically sewing or fusion with a wedge welder that has the heat turned down and the speed turned up. And, personally, I think that's better. It doesn't catch and the stitch doesn't come out. The chapter also discusses cable ties for geonet connections, mechanical connections for perforated mini pipes, and the importance of subgrade smoothness and overlap quality to preserve drainage continuity. Next one, please. So these are the chapters that are coming. They're actually already written. We just have to go through and kind of approve them again. And the manual is a living document. It's going to be upgraded. It'll change. We'll have different versions and suggestions that you may have. Say, hey, that doesn't work here. Then you need to change that. We'll listen. We'll come through it. So chapter 13 is going to focus on the geotextiles that are used, how to use them, how to not strip or comb the fibers by pulling across the other materials. Chapter 14 focuses on the appurtenances, talking about pipe penetrations, concrete attachment, and all the other tedious details that are covered in the chapter. Electrical leak location surveys for chapter 15. Mentioned these earlier, and I'm a firm believer that these surveys save money and time while protecting the parties involved in the supply and installation of a waste containment cell. It's hard to put a price on the aggravation and time spent trying to find a leak. For me, it's security. I can say that I put it in and now show me where it's leaking. It must have happened after I installed it. Post-construction for Chapter 16 goes back to the documentation and panel placement logs and drawings. If you didn't document it, it didn't happen. In almost all cases, or all areas rather, without a proper report on how the cell was constructed, a use permit is not given to place trash in the new cell. That's it for the chapters. Now back to you, Brian.
Brian, you are muted. Could you please unmute?
Yeah, I'm unmuting. Are you seeing my screen? Hello?
Yeah, but it's like zoomed a little bit.
Okay, yeah. Let me go back to that. See if I can unzoom that. There we go. Okay. So, yeah, just with IAGI experience shows, and IAGI places a high priority on quality installation, workmanship, and safety. So we do see from time to time project failures, and so we really promote the wanting to see properly installed geomembrane systems and safe work practices. Just examples of some IAGI installations. A photo on the left is just proper sealed pipe boots and penetrations incorporating a proper extrusion welding, clamping methodology, and testing procedures. And the middle picture just showing proper geomembrane deployment and welding methods, including conducting pre-qualification welds, which we call T-seams, production welds, including wedge and extrusion welding, and proper testing, both non-destructive and destructive test methods. And the photo on the right just showing, proper connections of mechanical anchorage, utilizing the proper clamps and hardware and proper sealing methods, and testing these properly to ensure whether we're below fluid level or above fluid level, that we have critical connections. So over to you, Nick, to talk about Certified Welding Technician Program.
Thanks for that, Brian. Look, the CWT is a program that I've been involved with as I worked with an installer probably 13 years ago, to now as a proctor and working in our own CQA business. So I'm pretty excited to talk about the CWT program. Look, the CWT was initially designed and created as an internationally recognized standard for the geomembrane industry and welding technicians. In this section, I'm going to be talking about the CWT, which is Certified Welding Technician Program, the certification process, and what's required to become a CWT, and ultimately the function of proctors and what they can and can't do. So next slide, please. As explained, the Certified Welding Technician program includes separate certification assessments, and they're for the different types of material. We have, one for the HDPE, one for LLDPE, PVC, and reinforced geomembranes such as CSPEs. We don't do a lot of CSPE assessments in Australia, and hopefully we can increase the number of that with the water storage industry in South Australia, Victoria, New South Wales. By achieving this certification, the technicians demonstrate they meet some sort of industry recognised standard of competency, and gives confidence to contractors, consultants, and ultimately the asset owners for their installs. Next slide, please. Go. So the certification requirements, let's look at what it takes to become a CWT. To achieve a CWT certification, applicants must pass an examination or exam. It needs to be independently supervised by approved proctor by IAGI. Typically, this is going to be a CQA consultant, a supplier, or an engineer. They must also demonstrate practical industry experience, including welding of the proposed liner that they want to be assessed in, of 5+ projects. Okay, so HDPE and LLDPE, we're looking at 90,000 square meters of installed material. For the reinforced materials, we're looking at 50,000 square meters. And that's just a direct correlation with ultimately the size of reinforced material projects are a lot smaller in comparison to the larger HD and LLDP projects. Next slide, please. Cool. So the CWT certification includes both the written examination and the practical examination, as we've discussed. The good news for the written examination, it's now online, and anyone that's undertaken the CWT or organised it for the technicians it's a game changer, as it reduces the previous time that we used to have to request the paperwork. It would be sent by IAGI in the States, and then we do the examination on site, then send the exams back. So we still need to proctor and be present to supervise the candidates undertaking the exam. However, it's online now. The candidates then complete the welds on the applicable geomembranes under the supervised conditions for the appropriate welding technique. So if there's fusion, extrusion, and hot air for the CS or the reinforced, the completed welds are then packaged up and then sent to an approved lab, an IAGI approved lab, which is usually GuiLab accredited. And they're tested in accordance with the GM18, GM19, and the FGI 1126. Next slide, please. Cool. So look, we obviously with these, this is a bit of an example of how many tests are undertaken internationally at the moment. So look, just because you do the test doesn't mean you automatically get the ticket. As you can see here, the first time candidates have an 83% passing rate, and then the second time around 92%. So it isn't just a pay the money, get your ticket. There is a acceptance criteria for the certification. Next slide, please. Look, there's a fair bit going on in this slide here, but I can sort of break it down into what I believe is two main phases of what proctors or what we do. The first stage is technically the administration stage. Before any of the assessment, the proctors work with the customer or the client. We collect the required exam order forms and then the CVs. Now, the CVs of the technicians can demonstrate that 90,000 square meters of material that's been installed, and also the 5+ projects. And that's how we demonstrate to IAGI that this candidate is acceptable to become a CWT. The proctors, we can then direct the client and the technicians to the study guides for the exams, and also what is exactly required on the day for the physical sample welding. We then send the required paperwork to IAGI and work with Laurie and Paige, who do a great job over in the States. And we streamline the certification process for the client. Then ultimately, the client or our client or the guys organising the tests, we need to make sure that we've got the right combinations of HDPE, LLDPE, PVC or reinforced material, as there is different combinations, but we go through that more detail when we're engaged. The proctor can assist the clients by if we don't have the material, we can recommend other manufacturers that would be able to send the samples out for the test. Well, ultimately, what I've done in the past is connect lining contractors and contractors up to other lining contractors to sort of hand over or supply or sell other thickness materials, which has been a pretty big help in the past. Then the second phase is ultimately taking the test. So the proctor ensures that the correct test materials are available. They meet the lab test requirements and the matrix for the test. But again, contact a proctor. We can take you through the whole certification process there. It's better one-on-one. But next slide, please. Now, look, IAGI are always looking for new proctors. So, as I said, email Laurie or Paige in the States there. But ultimately, from the Australian or Australasian audience that are on this this webinar, contact myself direct, and I can point you in the right direction to Proctor in your region. There also is a Proctor refresher training course, which is coming up. Well, it's current now, and that's to reflect the new CWT processes with the online examination, just to go through and consolidate what materials and thickness are required, just to streamline that process a little bit. But yeah, look, reach out to Laurie and Paige. As I said, they do a great job, and go from there. Next slide, please. Look, down here you can see a few of the examples of what we've just discussed in regards to the physical tests. So I think there's Gus in the middle there. Gus is an IAGI proctor and has been for many years. And this is a typical example. So down the bottom left-hand corner, you can see the technicians undertaking the written assessment. And there you've got the physical wedge welding and the extrusion welding. Next slide, please. So I'm going to hand over to Todd there to discuss the approved installation contractor program. Over to you, Todd.
Great. Thanks again, Nick. So we started with the CWT. That was for the technician. And that's great. The technicians need to be, acknowledged and their proficiency in being able to weld, and they're doing a good job. That doesn't help the contractor. I'm sure this doesn't happen in your part of the world where you get somebody a CWT and then they move to another company. Oh, that's great. They're getting paid more over there, and then they want to come back after that job's over. Well, that doesn't help you to keep your certification of having enough techs, but you need to be certified. The contractor needs a program that can help with professional installers doing professional installations. That's AIC, and that means that's for the company. Next slide, please. So the AIC program is developed for an industry that needed a way to highlight the best, the ones that always do a great job. Leachate's dangerous if it leaks out and gets into the environment. AIC is what you need to specify for those types of jobs. The pictures on the right show a lagoon that an AIC contractor has installed, and they're doing all the battening, concrete attachments. They're doing pipe penetrations. You're not going to give that to someone who's never done this before. That's why you need AIC. Next, please. Again, approved installation contractor. The program aims to promote growth and provide better quality workmanship to recognize geosynthetic installation companies that meet a minimum level of professionalism, ethics, and business practices. They must meet corporate history and business practices, insurance verification, safety training, and professional competence and experience. Okay, next, please. The key elements that must be submitted for AIC third-party review and verification include company history and information. How long have you been? What's your history? What types of sites have you been doing through most of your history as a company? There's a minimum of 500,000 square meters or 5 million square feet installed annually. And you have to prove that. You have to show that you do that. The ability to be bonded. And for most of Australia, and I think the rest of the area, that's really a letter from your bank saying, hey, they've got the capacity funding-wise to be able to finish the job. That's what bonding does for us. It means it's an insurance policy that the job will get done. If we walk off because we can't finish, there's someone there to finish it. You have a similar piece in place. Proof of general liability, workers' comp, and vehicle insurances. Again, just showing that you're insured and following all the standards. Safety training programs, drug-free work program, health and safety orientation. Now here's the technical part of how many, you have to have CWT. 15% of the crews must have CWT welders on the crew. So 12-man crew, that's 2 guys. That shouldn't be hard to do. And we're typically a 12 to 13-man crew, so we're at least 2 or 3 people. Some it gets to be half. Like I'm been a strong proponent of this for 20 years, so we keep pushing it as much as we can. 2 letters of recommendations, each dated within the previous year from engineers, general contractors, and owners, and also geosynthetic manufacturers. Next, please. The importance of specifying for IAGI, AIC, and CWT. You get industries tested and vetted. You get bonded, insured. You know they're good. Certified and professional crews, project risk management, which includes safety, quality, experience. If an owner's looking at where do I get the best, you got to look at IAGI, you got to look at the CWT and the AIC programs. That's where you're going to find it. There is no other program like it anywhere in the world, and I'm definitely in for the long haul with this. I think it's great. And that's it for that. Next, I think it's back to you, Brian.
Yeah, I just want to make sure I'm unmuted. Okay, can you hear me?
Yep.
Okay, I'm toggling between screens. Okay, in addition, we just a couple updates with IAGI. We, in addition to our municipal solid waste new guideline, we are working on 3 individual guidelines that will hopefully be released and put on our website by the end of this year. One will be a guideline, IAGI guideline on air pressure testing. One will be on vacuum box testing, and we will also be doing one on constructing T-seams. So look for those by the end of 2026. And just showing you some work from AIC certified contractors, just complex landfills, different configuration closure systems on the left, and then the right system as well, a closure system incorporating the one of the supplier turf closure systems incorporated with the lining system. Also, just some of the things that we're starting to see in the industry, not just double line. This is a triple lined containment for produce water, 6 layers of geosynthetics, 3 layers of 1.5 millimeter HDP, 2 layers of GeoNet composite, and a layer of geotextile. So as we move into more critical containment, environmental regulations are starting to look at complex multi-layered containment systems. And just a nice project that came out of Australia, just a unique, challenging, I think compliments of GeoQ, who was involved with the CQA on this job, one of the largest line brine ponds, I believe, in the Southern Hemisphere, done in 2025. So just some of the great workmanship being done in the industry and with affiliated with IAGI installers and members. Over to Todd to talk about a message from IAGI's president.
Thanks again, Brian. Thanks everyone for joining us. An in-depth look at IAGI and the best practices manual. I got to tell you, this has been something I've wanted to do for a while, getting back into Australia, because the name Hallaton came from a company that we bought off the shelf in Canberra. Myself and 3 other gentlemen. An architect from Washington, D.C. was down there for 2 years on kind of a sabbatical, helping to do some landscape architecture. And he called me up and said, and this was 1986. He said, they're like, it's a few years behind down there. I was on a plane 2 weeks later, and we bought the company off a shelf and stayed with it for about 8 years. And then I got married and everything else changed. So that kind of changes it. And I got to play in some rugby matches while I was there. So I thought that was fun. So IAGI wants to ensure high standards of quality, safety, and productivity. IAGI represents members from some great design engineers, CQA companies, owners, manufacturers, and equipment suppliers. IAGI is the source for information and best practices supporting geosynthetic installations. New initiatives. We have a new website, new CRM. The BPM is for use by installers and anyone working with geosynthetics. More training videos and some new installation guidelines are coming. IAGI is ready for a lot of growth. Next slide, please. Geo Games. This will be the 4th Geo Game. It's going to be at the IGS meeting in Montreal in September. If it's, I believe, on Wednesday of that week. If you're there, please come. Everyone's welcome. It's going to be a lot of fun. If you've seen one before or any of the other videos, there's been a lot of people there, and it's going to be great. Now, something that I pushed this year with the teams, there's 20 teams, 10 companies, and 7 countries represented. There's a big push to lower the temperature of the seaming of the geomembranes. So we set it at 750, 400 degrees Celsius. And if you're a good technician, you should be able to get it to weld without a problem. We're trying to lower the temperatures depending on what happens with the results that are coming out, but it's something to be watched. A special shout out to our main sponsor, Agru. They've supported us as a main sponsor since the first, and this is the fourth. Next, please. This is the meat of the presentation to me. I think it's awesome that we're starting our first chapter. I think it's great that Nick gets to represent us. And I think, hope everyone listening gets involved and can help out in some way. So go ahead, Nick.
Yeah, thanks for that, Todd. Look, I've been talking to the IAGI team for probably the last 5 years and supporting the CWT, the Proctor side of things, and also the Australian AIC contractors here. But a big shout out just to refresh back to a couple of pages ago. We had a project where there was a designer that specified CWTs. We had an installer, FabTech, who was AIC, and GeoQ was involved with the CQA. So an example, of what we can bring to the Australian side of things is supporting the AICs, the CWTs, and it formed that link between the American international side of things, because they do cover the globe. So I'm excited that we're going to be the first chapter, to sort of the guinea pig, so to speak, for other chapters to roll out around the world. And I'm super excited to have Alex Gersh from Layfield, Todd. Todd's going to be represented in Australia as well. We've got Warren Hornsey, Jonathan Shamrock, Graham Brown from an installer perspective, and Alicia as well. So I think between the suppliers, the designers, and the installers, I think we can do some great things in Australia. So the Australian chapter is live as of today, and I'll be in contact with a lot of my clients, installers, to give further information on that. Thank you very much, Todd. Thank you very much, Brian, for the support there as well.
Okay, and thank you, Nick. And so we're just going to wrap up here and just quickly visit us at IAGI at IAGI.org is our website. You can get information on our membership and the different types of members. You can find out all the different applications and information for applying for CWT programs as well as AIC. And jump over to the right, the resource and publications. We have really well noted IAGI guidelines for installing HDP, LLDP, PVC, and different reinforced geomembranes. Again, all available from our new website. And just again, I also want to just thank behind the scenes, and not just our board of directors. To the left is Lori Huntingford, our managing director. She's been with IAGI for close to 30 some years, so she knows IAGI inside and out. And we've 2 years ago, to her right, we hired Paige Richards. Paige has been in the industry for a number of years, and she handles all of our CWT. She's our CWT coordinator, handling all CWT. So please reach out to Lori or Paige, depending on what you need. And I think that's it for us. Alicia, I'll stop sharing if that's okay.
Thank you, Brian, Todd, and Nick. Alicia, if you can do your case study now. Thank you.
Hi, everyone. Usually know me as Secretary of ACIGS. Today I have my Merit Lining Systems hat, as I'm Business Development Manager. And I have 2 study cases today: installation of geosynthetics in landfill and installation of geomembrane. Can you see my slide? Oh, here. There we go. So meet our team. We've been in the geosynthetic market for the last 36 years. And we have very skilled people working for us. Our supervisors are with us since 15 years, so they know what they do. We know IAGI for a very long time, and we are members of IAGI. Our crews are certified welding technicians. Apart from that, our suppliers have S26 safety certificates, which are very important now on mine sites. Actually, about approved installation contractor, I found out just a few weeks ago, so I actually wasn't aware of that. So it's good that actually we have this webinar. And now we have applied for that, and we are in the final stage of getting that approved. First study case is landfill cap in Queensland. So it was done last year between June and August. The coverage area was 117,000 square meters with different types of materials on the slopes and on the flat areas. So there were two types of GCLs, smooth and double-sided textured 1.5 millimeter LLDP liners, geocomposite drainage with geotextiles attached, and 61 vertical gas pipes. With the installation, we had 10-person crew on site with QA engineer. Out of these 10 people, we had 4 welders with CWT certification. After successful trial pad, we had permission to actually drive on top of GCL with the telehandler with turf tires. That project was 100% supervised by CQA reps. Challenges: 28 rain-affected days with 147 mils rainfall, which is not great. However, despite that project was completed 6 days ahead of schedule with over 17 kilometers of welding done. And this was really great because we had 0% failure rate after independently tested 84 DTs. All the QA package was submitted within 14 days of completion. So we think that key to the successful project is welding. So that's why these study cases are focused on welding. Another study case is primary crystallizers on mine site in WA. We started that project at the end of January. It's still ongoing. So far, it's been installed 3,650,000 square meters of geomembrane. And the full project is actually, I think, the biggest geomembrane project in the world, which will cover 17,300,000 square meters for primary crystallizers, and there will be additional liner in secondary and KTMS crystallizers. We are head contractor on that project with JV partner as our subcontractor, Jaylon Industries, and other civil works done by McCosker's Contracting. Materials were supplied directly to the principal by Solmax, Atafil, and BPM. So there are different roll sizes, which is quite challenging sometimes. Scope of works for us is project management because our operations director is there trying to get everyone in line. So civil works, sub preparation, anchor trenchers, minor civils, geotextile and geomembrane installation. Just geotextile is not installed everywhere. Typical crystallizer metrics. So we have at the moment 64 people on that site together with all the subcontractors, with 30 men working on night shifts installing liner. And so we have 2 crews and production is 500,000 square meters of geomembrane in 1 cell. And it took us 32 days to install with some fusion welding, 68 kilometers of fusion welding, 137 destructive tests with 2% failure rate. There were some bumps which impacted our production and we lost a little bit momentum and had to restart our S-curves. Some other factors that were high winds up to 65 kilometers per hour causing risk associated with liner uplift, but also dust and visibility for civil works crew. Our crews work on night shifts, which is pretty tough on them. However, it mitigates effect of winds and plant interactions between civils crew and lining crew. Also assists management of wrinkle development. Aggressive pilbara environment requires thorough weld cleanliness practices. Cleanliness and suitably qualified technicians is key for the projects. So that's why we have these factors for the best welds as correct temperature, pressure, and speed balance, clean, dry, and properly prepared surfaces, stable environmental conditions, and skilled operators, and well-maintained equipment. All of that, it can be covered in IAGI specifications and manuals for welding. I think it is available to everyone. So that's why we often recommend that specification as a base to design, or for someone who doesn't have a designer involved, so that they can have a look at it and know what to expect. So IAGI installation specification ensures high quality, consistent welds, proper testing and verification, skilled workmanship, reduced risk of leaks and failures, and strong documentation and traceability. That's me. Thank you.
Thanks, Alicia. Yeah, so just probably some closing comments from myself. We don't have too many questions just yet. So the real place that I see the best practice manual fitting in is for jurisdictions where there's no national specification for how to do this kind of work. So I came from originally from South Africa, where there's a national standard on how to weld geosynthetics together, into a country where there is no national standard. So you're into the land of bespoke specifications, and bespoke specifications are fine, except for the stuff that they leave out. So when you're reviewing those specs, you review everything that's in there and it all makes sense. But then there's those little key bits that get left out that really catch designers on the job site when you're busy installing and a contractor's doing something that doesn't look right to you. You go back into your spec, oh, it's not covered in there. But if you refer back to something that's got that industry experience and knowledge built into it, creates a real good reference. So I've been pushing pretty hard to get the best practice manual included in, even in your bespoke specs. Just mention it, because it just gives you that additional avenue to, if you're not sure about something, to go back and check and say, is that good practice or not? So I think that's where that really does fit in. I think it also fits in, and if you were listening to our electrical leak location webinar a few weeks ago back, we spoke about quality systems. So as a designer, we think about lining systems. We don't think about the geomembrane by itself. We think about how the geomembrane and the GCL work together, how the drainage layer above helps reduce head and reduce leaks. So thinking about liner systems, and then thinking about liner or geosynthetic installation quality. You can front load it with a lot of what we've spoken about today, getting the spec right, getting the materials delivered correctly, installing them correctly, and then doing QA and maybe an electrical leak location at the end of that. All of that provides owners, the people who ultimately carry the liability or the risk, the peace of mind and the confidence that this work has been done well. And I really see that's where the certified welder program and the ARC program comes into it as well, is that just removes that initial risk, especially if you're going out onto open tender, because a guy with a ute and a couple of welders thinks they can do the job, and if the owner's accountants aren't that aware of what goes on site, man, that can end up pretty bad. So I think that's also probably another key kind of layer of ensuring that those quality systems are in place right from the start of a project. Just a question that did come up: is there a list of currently accredited ARCs in Australia and New Zealand? And if so, where can people find that?
You can get it on the IAGI website, has all the AIC members. So if you're specifying it and you want to know who's in your territory, it's definitely there. We don't put CWTs there because of what I talked about, contractors stealing your CWT people, calling them, and try to keep that a little bit more secure.
And the other key thing, which Todd just mentioned now, which I'm very keen to see the outcome of, is the reduced welding temperatures at the GeoGames. So that is something that people like Kerry Rowe have been speaking about for a while. Is what is the impact of higher welding temperatures on the long-term durability of the geomembranes, and is it possible to get good wells without heating that well zone and that heat affected zone? So yeah, I think that's probably a real practical case study on how that's going to how that could practically be rolled out onto job sites. So yeah, really keen to see how that turns out.
And that started in Rome on actually your panel that I was on with you. We talked about it. It came up then, and it still hasn't gone very far, but it's growing. It's coming around.
There is a panel discussing it at, as you know, Jonathan, in an ICG in September in Montreal. Queen's University has actually done a lot of testing and published some papers, and we'll be discussing some of those. And we do need to see a little bit more industry research. IAGI would like to be involved helping with that. I know Todd and our board were concerned with extreme high temperatures and OIT reductions, and we'd like to see more testing, see the science behind this, but hot, and not just that, just extrusion welding, second, third, fourth heat cycles. We know it has impact on polymers. So
yeah. Awesome.
Pete Meyer from South Africa has samples. When he was on the board a little while, he helped with a lot of the manual. He has samples from 30 years ago that they've been pulling out, and the seams don't fail, but they've decreased in strength, peel and shear.
Yeah. Well, something to look forward to, and if you weren't already going to Montreal, a really good reason to be there. I'd just like to thank everyone on the panel today, and congrats, Nick. I didn't realize it was day one today, so that's awesome news. And I really do think that this will provide project owners with a lot more confidence that their risk has been looked at right from the start of a project. Thanks all. Have a good day.
Thank you.
Thank you.
Thank you, everyone.
Thanks.
Thank you very much.